In this video, we're talking about drawing a graph that represents a situation, okay? Represents an event. So here's our situation. It says you are going on a long car trip. You are driving on the interstate. Then you stop for a quick lunch. Then you get back on the interstate. After a few hours, you get slowed by heavy traffic. You finally reach your destination. So that's our event. What we want to do is draw a graph to illustrate the distance traveled over time. So I've started out with my x and y axes, okay? So I'm going to go ahead and label them. So my x-axis will be the time, okay? Time is always our independent variable because you can't stop time. As much as we would like to, not going to happen. So the y-axis is going to be the distance we travel. Now, for these problems, you don't have to put numbers on this side, okay? Up here, I haven't told you how many hours we were on the interstate. I didn't tell you how long we stopped for lunch. So we're just looking at a general idea of what the graph would look like, okay? In this case, we're going to start out here at the origin. We don't have our other three quadrants because for this situation, negative numbers won't make any sense. Okay, so we're only looking at the first quadrant. We're starting at the origin because that's time 0 and we haven't traveled anything. So the first thing we do is we're driving on the interstate. So usually on an interstate you're driving pretty quickly and you're driving at a pretty steady rate. So our line is going to be coming up and it's going to be coming up at a consistent rate. Okay, it's not going to be jagged or swirly line. Okay. That's going to be a pretty straight line. So the next thing is we stop for a quick lunch. So this isn't going to be much of our time. Now, some people want to say that when you stop, it's going to go down. But remember, our y-axis is talking about the distance we've traveled. When we've stopped for lunch, we haven't decreased the amount we've traveled, that we're just not gaining anything. So we're going to have a little plateau here, okay? That our quick little plateau, here's our lunch. That we're taking up some time, but we're not getting any farther. Then you get back on the interstate. So from here, it's going to go about the same as there, and it's going to be going up. Now, after a few hours, you get slowed by heavy traffic. Well, we're still making progress, we're still going, but now it's not going to be as fast because we're going with slower traffic. So I'm going up, my distance traveled is going up, but it's not going up as quickly, okay? So then we reach our final destination, so our time has stopped, okay? So here's the interstate, we're going with time and the distance, stopping for lunch, getting back on the interstate, oh, we hit slow traffic, so we're not increasing as much, all right? Now, here's another one. Sorry. Here's another one. So if you want, you can try to do this one on your own and then press play to see how yours matches with mine. So this says you are going on a long run. You start out quickly, then you have to stop to wait for a car to cross your path. You start back up, but you don't run as fast as before. As you approach your stopping point, you sprint to the finish. So now we want to draw a graph to illustrate your speed over time. So again, we have our x and y axes. Again, our x is going to represent our time. Our y is going to represent this time, our speed. And again, we have no numbers. We can't get any more specific, so we're not going to include a scale. Okay, we're not going to put numbers over here. So, we start out running. So again, when you start out running, it's time 0, and you start from a dead stop, okay? And as you're running, we're running pretty quickly, so our line's going to be going up pretty quickly. But it's also going to, our speed is going to be increasing. You don't go from 0 all the way up to 20 miles an hour instantaneously. You have to go up. So we're going to have our line going up. Okay, so we're running pretty quickly. So this is our speed. We increase our speed. Oh, we have to wait for a car to stop. Okay? So maybe here we're running for a little bit. In this case, we run for a little bit, and then we keep our same speed, but then now we have to wait for that car. When you're stopping to wait for that car, again, we have to slow to a stop. Hopefully that you see the car coming and you can slow to a stop. Now, this is a little different than our last graph. Okay, so let's look at this. So when we're starting out running, we're increasing our speed to get up to whatever speed we're going to maintain as we're running. Okay, so here we're running at our consistent speed. Oh, a car's coming. I need to slow down. Now, because this y is our speed, we will be going back down to the x-axis, because when we're stopping for that car, my speed has to go to 0. Okay? Then we're going to start back up, but you don't run as fast as before. So I'm going to be going up, but I'm not running as fast. So this plateau isn't going to be as high as this one. Okay? So I'm speeding back up. Again, I can't automatically jump instantaneously to 20 miles an hour. I kind of have to speed up. Okay? So now we're running again at our consistent speed. Oh, we're getting close to our finish line, so I sprint. So I'm going to run faster, and my speed now with sprinting is going to be faster. Okay, it's going to be higher than I've been before. Okay, then we reach home, and we stop. So this is going down to our x-axis. I'll need to continue that out. Okay, so looking at this, we're building up to our speed. We keep our speed. Oh, we have to stop for the car to pass. This may have a little bit of time here. Okay, depending on how long you want to say you waited for that car. Maybe you just stopped, it passed, then you started back up. Okay, so we're starting back up. We're running at a consistent rate. Oh, we're getting close, so I need to increase my speed to my sprint, and then I slow down because I'm at the stop. Okay? These are, for some people, these can be a little bit difficult because you really have to understand the graphs and what the lines are representing. Okay? So think about the two different situations. Here, our straight line, our plateau, meant we were keeping our same speed. Whereas before, we were keeping that same distance. Okay, so you really have to think about what the two axes represent and how that relates to your graph.